Hello everyone, welcome back to another video. So if you have seen the yesterday's video on the daily challenge, you know what this video is about. And but if you have not seen this, what I'm trying to do is I'm trying to solve daily challenges uh, while recording myself. And I haven't seen the daily challenge question till now. I will just open it in front of you and solve this, and after solving in parallel I will also tell you my approach, and after solving I will explain the complete tutorial. Now let's just move into the problem. Okay, this looks interesting. So in this question we are given n into n integer matrix. Minimum sum of path falling path with non-zero shifts is a choice of exactly one element from each row of grid such that adjacent rows are in same column. 157. So these are all possible choices. 359, 357. This is pretty standard question. To be honest, this should not be in hard. This is a pretty standard DP question, and I don't think this negative also bothers my approach, my DP solution. So let's just write the DP solution first, then I will just explain them. Constraints are also very low. I can either write uh, n cube solution. Let's see. So first n equal to a of 0. Let's start. First row will be like this. We can start with this, and I can either write an n cube solution or n square log n solution. I'll just write n square log n solution with multiset. I'm iterating in each row, and I'm also iterating in column each column. Well, I will calculate. First I will erase the the previous element, that is dp of j, then calculate answer if first size greater than 0 answer, and I will insert this dp of j, and I will update current dp of j equal to plus e of I of j, and I also need to update the multiset. So we have to choose exactly one. Okay, Not skipping any row is also not possible. Hmm, what happened here? Is so I have to find minimum, right? It should be st dot begin, and this should also be. Hmm, let me just print all the object first. So this is 6 is 7, and this is 7 plus 6. Why this is going wrong? I think so. This cell of 7 is 2 comma 0. Why I'm getting 7 here? 1 0 is true, 1 1 is 1, 1 2 is 1, and this prints. Now for 2 0, why I'm getting 7? Uh, so multiset I have to erase like this. I cannot erase the simply similar to set, because there are multiple occurrences. If I just write st dot erase and value, it will erase all the occurrence uh, of that element. So to avoid that, what I have to do is I have to write st dot find first, so it will remove first element that is equal to dp of j. Now I think this should work. Yeah. So this is definitely not a hard problem, I would say, but this it's similar to this week's weekly contest 394, I think third question. It was similar to that, in which we are given we have to find some maximum sum in grid type of structure, and it was similar to this only. So let's see the editorial for this. First of all, uh, my observation in this grid type of questions is you always need to try all possible combinations. A greedy type of solution will not work. And second observation here was that there is condition of no, there should be no elements in chosen in adjacent rows. So for a unique recursive call, if I would have done this with using uh, recursive DP. What my state would be? It would be current column and previous index of uh, current row and previous rows uh, which index I have used. So that would be my unique recursive call. So let's say I have this type of grid. So just I think Wi-Fi got disconnected. Let's say I have the grid of first sample test case, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now uh, let's create another DP grid of n square in where in I and jth position I throw jth column. What I'm storing is I rows are processed, means first I rows are considered, and the whatever sum I'm trying ends at jth position. So let's start with first cell itself, which is 0 comma 0. Now 0 comma 0 represents that there I'm considering zeroth row till zeroth row, means only first row, and my whatever falling path sum is, that path ends at jth position, that sum will be equal to 1 itself. Then I'm considering, let's say, 0 comma 1. Then zeroth row, all the rows from 0 to 0, that means first row only, and ends at first column, this will be 2. Similarly this will be 3. Now this is where what you can say, the more important transition comes. I'm at first row and 0th column. Now I have to consider all these rows. Now this can either be this type of path where I'm coming from 2 to first column of 0th row to 0th column of first row, or this can be this type of transition where I'm coming from uh, second column of 0th row to 0th column of first row. Now what can be the maximum answer here? 4 is my constant which I have to add, obviously, but I will take maximum of this. I don't care whatever happened above. I just care the path till jth column was max, or the first column was max, or second column was max. So what I will add here is 3. So answer at this position I have to take minimum, right? So 4 plus 2, which will come out to be 6. Similarly, for this case, 5 is my constant which I have to add. Now what options I have? This 0th column and second column. So minimum of those, so 1. So this column value will be 6. Now for this row, this column, I can either take this or take this. So 6 is my constant. One minimum of 1 and 2 will be 1, and column here will become 7. Now in while filling for 7, 7 is my constant. I can't take this above because the condition of adjacent rows, either take this or this. Minimum of 6 and 7, so 6. Similarly here, 8 is my constant. Take minimum of 6 or 7, which is 6, 14. And 9 is my constant. Take either this 6 or this 6. Minimum of both of them is 6 again. Now when I am at last row, what it represents, n columns, n rows are processed, and it is ending at jth position. Now whatever minimum answer we get in this row is my final answer, because we basically have to process all those n rows. We don't care at which position it ends, as long as it satisfies the adjacent pair condition, which we have already checked above. So minimum of that last row is my answer. Now I can do this in n cubes type of solution. So whenever I am at I and j position, I throw an jth column. I will iterate in I minus 1 row dp vector for j1 uh, 0 to n. But I cannot consider the condition where j1 equal to j. So this condition I have to ignore, and all other I have to take minimum of that value stored at that dp vector. Now this solution will be like n cube, first n square for each cell and this additional n for each cell again, so n, it will come out to be n cube. Now other solution is n square log n, which I used. So in that, what I can do is, let's say first row I have processed, which is like 1 2 3 4 5. This is the dp vector, let's say, and now this column has aij value as 4. Now what I can do is, I will store all the above row, just one above row, in an multiset, and update that multiset while moving to next row. And in this multiset, if I am checking for 0th column, what I will do is, I will erase this element from multiset. So this element is erased. Now I will take the minimum element. How I can take this? By just writing st.begin, because multiset is uh, ordered multiset, and first element will give me minimum answer. Now after proceeding this, after calculating minimum, I will update this value as 4 plus 2. Before updating, I will insert this one again for processing next columns. Now this, if this was 5, I again have all the elements in multiset. Now I will erase this 2, because upper rows same column I have to erase. And then I, I have 1 3 4 5 in my multiset. I will take minimum and add the aij value 1 plus 5. Similarly, I will keep doing this up till this column, and while moving to next row I will clear this multiset and insert all these values in the multiset. So I have to keep updating multiset because for ith row the important values are in I minus 1 I minus 1 row. So if I am moving to I plus 1 row, I will need values from ith row. So updating that multiset is also important. So this will be having n square log n complexity. So I can use both the solutions, and I think this was definitely not an hard problem. If you see, this is a standard problem. This kind of concept is very repetitive. So I think that's it from my side. I solved this again, and I will also upload a video for tomorrow's daily challenge. And thank you for watching.